Hello, Algebra 2 students. Today we will be doing 12.1 notes, define and use sequences and series. A sequence is a function whose domain is a set of consecutive integers. If a domain is not specified, it is understood that the domain starts with 1. The values in the range are called the terms of the sequences. Let's look at the information below. So the domain is the input. So you have 1, 2, 3, 4. Usually start with 1 unless it's specified differently. And the range are your terms of the sequence. This is called the first term. The next one is the second term, the third term, the fourth term, and so on. This is the nth term. And so the domain is just the position of each term, and the values in the range are known as the terms of the sequence. A finite sequence has a limited number of terms, so it has a beginning and an end. So if you look below, 2, 4, 6, 8, it ends there. There's no 10, 12, so on. When you have the so on, you have the 3 dots after the sequence. That type of sequence is called an infinite. An infinite sequence continues without stopping. So it has a starting point and then keeps going, but you recognize a pattern. A sequence can be specified by an equation or by a rule. For example, both sequences above can be described by the rule the nth term is equal to 2 times n, or f of n equals 2n. We are going to write the first 5 terms of the sequence in example 1, a and b. So let's look at example 1. The way you read that is the nth term is equal to n minus 5. And so they are asking us to find the first 5 terms noted by the first term, second, third, fourth, all the way through up to the 5th term. So to figure that out, you are going to replace n with 1 for the first term, n with 2 for the second term, and so on. So I'll do my work here. So I'm going to replace n with 1, 1 minus 5, that gives me negative 4. Second term, 2 minus 5, and that gives me negative 3. Third term, 3 minus 5 gives me negative 2. 4 minus 5 equals negative 1. And finally, my 5th term is 5 minus 5, which is 0. Let's write the first 5 terms of the sequence. So here's the proper way to write them. So write each term separated by commas. So negative 4, negative 3, negative 2, negative 1, and 0. This is a finite sequence because it's telling you to find the first 5 terms. Okay, for the second example, we again will replace the n with 1 and then 2 and then 3 and so on. So to find the first term, it'd be 2 to the 1 plus 1. That's 2 to the second, which is 4. Next one, 2 to the 2 plus 1. It's 2 to the third. 2 times 2 times 2 is 8. Third term, 2 to the 3 plus 1. It's 2 to the fourth. 2 to the fourth power, 16. Fourth term, 2 to the fifth. That's 32. We've seen 2 to the fifth so many times this semester, it should just click that it's 32. And the last one, 2 to the 5 plus 1 is 2 to the 6. And so just multiply 32 times 2, and that's 64. And so our terms of our sequence are 4, 8, 16, 32, and 64. If the terms of a sequence have a recognizable pattern, then you may be able to write a rule for the nth term of the sequence. So let's take a look at example 2a. Now, sometimes it takes a while to recognize the pattern. Both of these are infinite sequences because they have the dot, dot, dot. So let's find the pattern first. Some of you may see it right away, some of you it may be difficult. But if you look at, these are the terms of the sequence. And we want to look at the position numbers. So the first term, if you look at 1, the second term is 4, third term is 9, fourth term is 16. To get 1, 4, 9, 16, here's the pattern. To get 1, you did 1 to the second power, 1 times 1. For 4, you did 2 to the second, 9, 3 to the second, 4, or 16, 4 to the second, and then dot, dot, dot. So that's your pattern. And then the next term, so your next term will be your fifth term. So proper notation for the fifth term, the position number should be your subscript. So the fifth term will be equal to 5 to the second power, which is 25. Okay. And finally, the rule for the nth term. That's for any generic term for this sequence. So rule for the nth term. And proper notation for the nth term is a subscript n, so a sub n. So the rule for the nth term is you take the position number. So the next one would be 6 to the second. The next one after that would be 7 to the second. So that's changing. So n, so it'd be n raised to the second power. And that's your rule for the nth term. Okay, now let's take a look at example B. So we have -3, 9, -27, 81. This one's a little easier to recognize. You see that every other term changes sign. So you have a negative number, then a positive, then a negative, then a positive. So you can tell that signs are changing. So there's going to be a multiplication. But you also know, hopefully, that, well, hopefully you're seeing something. So the pattern, if you take the first number, -3, the only way you can get +9 is if you multiplied by -3. And then 9 times -3 is -27, -27 times. But here's the pattern. So -3 raised to the first power gives you -3. -3 raised to the second power gives you 9. -3 raised to the third power gives you -27. And finally, -3 raised to the fourth power is equal to 81. And it continues. But now you can see that that's the pattern. The next term will be our fifth term. So you have the fifth term is going to be equal to -3 to the fifth power. So that would be the fifth term is equal to -243. You know it's going to be negative because it's an odd power. So that's what the fifth term is. Okay, and the rule for the nth term. The nth term is equal to -3 raised to the nth power, because whatever that value would be. So that changes. It's the exponent. All right. Going to the back page, we are going to talk about series and summation notation. We'll talk about both in depth more throughout this chapter. When the terms of a sequence are added together, the resulting expression is known as a series. So in the first page, all we did was we came up with the terms. But if I had said, what's the series for the first sequence? For like example 2a, you would add 1 plus 4 plus 9 plus 16 together, and that would give you 30. We wouldn't worry about the fifth term. Okay. So here you have the two types of sequences that we discussed earlier. A finite definitely has a beginning and an end, and an infinite continues forever. You can use summation notation to write a series. So it's called summation. Summation meaning adding. Notation, and there's a special symbol to use when you're using summation, and that is this Greek letter sigma. So to write 2, 4, 6, 8, and we already knew what the rule was, it's 2 times I. Well, you can use N, you can use K, you can use any letter you want. In this example, I is used. So I is from 1 to 4, and why is it from 1 to 4? because there's 4 numbers in our sequence. There's 2, 4, 6, and 8. So you start at position number 1, you end at position number 4. And that's how you would write it. So this is the correct notation to write 2 plus 4 plus 6 plus 8. So I'm going to erase that. Okay, if you look at the second one, if it continues forever, you have I equals 1, but then the top will be infinity because there is no ending point. And that's the only difference. So an infinite will have the infinite symbol, and a finite will have a beginning and an end. So here's how you'd read that. The sum of 2I for the values of I from 1 to 4. The second one would just be the sum of 2I for the values of I from 1 to infinity. So in the Greek letter sigma, this is how you make it. Like that. The index of summation is I, but it could be anything. So N, K, whatever. The lower limit of summation is the starting point. So the bottom number is the starting point. And the upper limit of summation is the ending point. If there is an ending point, if it's infinity, then there isn't. But it's still the ending point. Right. In examples 3a and b, we are going to write the series using summation notation. So here's the easiest way to do these type of problems when they're going to be, figure out what the position numbers are, but you want to make a space for 0 to help you when it's linear. This is linear because if you see, you're adding 3 to each number. 4 plus 3 is 7. 7 plus 3 is 10. So the best way to do it is to make a spot for 0 and say this is position number 1. So the first term is 4. The second term is 7. The third term is 10. And so on, all the way to whatever. It ends at 46. So here's the easiest way to do this particular problem. You could, for this particular one, you just kind of have to figure out where your ending is going to be. So the best thing to do is write an equation for it or make a table. So I tell students, make a table. It's not going to hurt you. And it's easy to understand. So we're going to make a table. Okay, and we're going to have 0, 1, 2, 3. The first term of the sequence is 4. The second term was 7. The third term was 10. Working backwards, this one would have to be 1 because 1 plus 3 gives you 4. And so we know what the y-intercept is. So this is our y-intercept. And our slope is 3 because our change in y divided by change in x is 3. So, and I got that by using the slope formula. So all I did was I took the change in y. So looking at these two, any of these, so even looking at these two, the change in y is 4 minus 1 over the change in x, 1 minus 0. I guess I should label which is which. So this is x, this is y. So I did the bottom row, 4 minus 1, divided by the top row, 1 minus 0 in the same order. And I got m equals 3. So your slope is 3. So to write it in y equals mx plus b form, our equation would be 3x plus 1. But we will just use we'll use different letters. So our equation in slope-intercept form is y equals 3x, 3 is our slope, times x, plus the y-intercept. And now we're just going to use summation notation. So we always start our series or sequence with 1. So you can use whatever letter you want. We can use n. So I'll use n. 1 to where will give you an ending term of 46. Well, let's write our rule here. 3n plus 1. A lot of students write this in parentheses, some don't. So you have to figure out 3n plus 1 has to give us 46. So you can solve an equation, subtract 1 on both sides, divide by 3, n equals 15. So your ending number will give you 15. So you have all these numbers you're skipping. Finally, you get to the 15th term, and 3 times 15 plus 1 would give us 46. So this is writing the series in summation notation. Probably thinking a lot of work for that. It's not too bad. It really isn't. The next one, if you look at the denominators, those are perfect cubes. So to get 8, you would do 2 to the third power. To get 27, 3 to the third. And you also have this first one. So I'm just going to... And 1 over, well, we know this is 2 to the third. This was 3 to the third. This was 4 to the third. Well, then this is 1 to the third. So 1 over 1 to the third. And so we know our rule. So our rule goes to the right of the summation notation. And it's n equals 1 to infinity because there is no ending. And our rule is 1 over n to the third. So our next one would have been, 1 over 5 to the third, and that would be 1 over 125. But we don't have to do that. Okay, in the last two examples, find the sum of the series. I like this part. This part's like easy for me, and most students love it. So if you look at A, your the sum, that's the sum of 4i from 1 to 5. That's how you'd read it. So you are going to add 5 numbers together. You start at 1. So remember, starting point, end point, or end number, right? So you're going to replace I with 1, and then with 2, then 3, then 4, then finally 5. You can't skip any. So you do 4 times 1 plus, and it's find the sum of the series, so you're adding the terms together, plus 4 times 2, plus 4 times 3, plus 4 times 4, plus 4 times 5. So this is 4 plus 8 plus 12 plus 16 plus 20, and then add the numbers together in whatever order you want. So that's 36. I got 60. So the sum of that series is 60. Okay, our next one, notice the starting point is not 1, so it's specified that starts at 3. So start, end. So you're going to replace k with 3 first, then 4, then 5, then 6, not 1, 2, 3, 4, 5, 6. So really pay attention to the lower limit of summation. So this one, we might need a little bit extra room, or I'll just write small. So we are going to replace k with 3 first, then 4, and then 5, then 6. So I'm going to do brackets. So 3 times 3 squared minus 7 plus 3 times 4 squared minus 7 plus 3 times 5 squared minus 7 plus 3 times 6, we end at 6 squared minus 7. So let's figure out what each term would be. So here we have 3 times 9 minus 7. So that's 18 minus 7. So it's 11. Or no, I'm sorry, 27 minus 7. Sheesh, which is 20. So you know what? Probably better to write it out. Okay, this one would be 3 times 16, because you do the 4 squared first, minus 7. That's 48 minus 7. Next one, 3 times 25 minus 7. That's 75 minus 7. And lastly, you have 3 times 36. I would use a calculator. 3 times 36 is 108 minus 7. So let's find each of the numbers that we're going to be adding together. So we have 20 plus 48 minus 7 is 41, plus 75 minus 7 is 68, plus 108 minus 7 is 101. Adding those 5 numbers together, and let's see, I get 230. And those are your notes for 12.1. Have a great day, Algebra 2 students.